When talking to customers, we've discovered that where most businesses struggle is combining disparate sources of data. They're bringing in external sources of data, whether it's third-party data from business partners or customers or public data attainable on the web, and these data sets come in formats differing from each other and from the company's internal databases, which include data warehouses, data from transactional systems, and various other Excel files and spreadsheets. Another complaint that we have been hearing is that if you're an analyst and you're providing insights to your managers or executive committee which could lead to million-dollar investments, you don't want to be providing insights based on incorrect information. Very often, these tasks are done manually, and as I'm sure you're aware, manual processes are very prone to error. And not only do you have to do these processes once, but months later you could receive the same data and have to do the same process over and over again in Excel. You're also under a lot of pressure because you're getting all these projects coming to you and you have to deal with them all at once. Think about how much time you spend building these reports for data marts. Wouldn't you feel more valuable and also enjoy your work more if you got to spend a majority of that time evaluating the results and driving business decisions? As an analyst, you first have to discover the data and assess the quality of information. Very often, this data is not properly structured in a way that can be useful, so you have to reformat the data. Once properly structured, you start to clean the data. And by that, I mean removing or fixing mismatched and missing data and identifying outliers or other data quality issues. Then, you can start enriching your data to create a master report or single view of the various disparate data sets that you're working with. Lastly, you must validate your results to ensure that you're not missing any information and that your data is ready for analysis. Usually, this process is iterative until your data is completely wrangled, and then you can continue on to the next step, whether that's building a dashboard in Tableau or displaying the data in a PowerPoint presentation. In this demo, we will play the role of an analyst at a manufacturing or CPG company, and we're collaborating with our retailers, our customers, to optimize their forecasts. The two retailers in this demo will be Acme from the Roadrunner cartoons and Globex from The Simpsons, and we're going to play the role of the MyCorp company. Unfortunately, each retailer has a different way of formatting and exchanging their data for our internal use, whether it's point of sales, promotions, forecasts, inventory, orders, etc. We want to compare each retailer forecast with our own open orders. So we will be combining data coming from Acme and Globex with our own company data. If forecasted orders are missing, we will have big issues, such as the retailer running a promotion and not receiving the associated goods. With Trifacta, we will show you how to avoid such problems and create comprehensive and accurate data. This demo will walk you through how to clean the messy data coming from Acme, format and unpivot the unstructured data coming from Globex, and enrich the data by appending the two retailer datasets and joining it to our internal company data. We'll then validate the data to identify any remaining issues, and lastly calculate our order fulfillment. Now we're going to get started with Trifacta. The first step, as I mentioned earlier, is going to be to clean the Acme dataset. But before we get there, I just want to show you a few ways that we can import the data. If we create a new flow and click on Import Data, we are presented with a few options here. We can choose from Amazon S3, an Oracle database, Postgres, Microsoft SQL Server. We can also upload local files that are already on our computer. To save time, I've already imported all of our data that we're going to be working with. And these happen to be Excel files that Acme and Globex provided me. We'll start the wrangling process by jumping back into the Acme dataset. Part of the forecast optimization is to make sure that we send the right quantities and volume. Let's clean up the product size column to start with. Now watch as I brush over these numbers. Trifacta learns from my interaction to predict the transformation that I want to complete. It gives me a list of cards at the bottom of possible transformations like extract, which will create a new column with these values, replace, which will replace these values with other values, count pattern, which will show how many times these values appear in this column, and many others. If we're satisfied with Trifacta's recommendation, we can add this step to our recipe, or we can choose from other recommendation cards. You'll notice that each column has its own histogram and data quality bar. This allows us to visualize the data in each column, giving the user insight and data signals in real time as the data is transformed, guiding the user to find anomalies and gain trust in the data. If you look at the data quality bar on the product size column, you can see that we now have two missing values. There's no way to get the exact size because the description doesn't show the size, and there's no way to interpolate it from the information that we have. So in this case, we're going to need to contact the source provider to correct this issue. But for now, we'll just delete the data so that's not going to mess with our analysis. There might be some hidden abnormalities in our data other than just missing values. So let's drill in a little bit deeper. If I click on the column details, Trifacta will show me the distribution of this column. And you can see here that Trifacta has identified a few outliers. Now they could be correct values, but usually data that deviates more than a couple standard deviations should be further inspected. When we visually validate the volume with the product title, it's clear that this was an incorrect entry in the product size column. It should have been 6.06. We can correct this by defining a rule. Trifacta provides a very guided approach to creating rules that are applied to the whole dataset. You'll see that we can choose a transformation function, in this case we've chosen set, select a column to apply this rule to, and the value that we would like our function to execute on. Lastly, we choose the parameters that we want the rule to apply to, and in this case we're just doing this one row. After correcting this issue, we can look back at the column details again. Now we can see that 606 is no longer an outlier, but we still have this other value that we have to look into. Looking at the description, it sounds like 198 milliliters is actually a valid value. The issue instead is that this column is not normalized to a specific unit of measurement, so we'll do that in a minute. But first, I want to briefly introduce the recipe editor over here on the right. At any point in the transformation process, Trifacta allows you to undo, edit, insert new steps, or just view previous steps in the transformation process. That way, if you discover that you made a mistake somewhere in your transformation, you don't have to undo all the progress that you have made. Additionally, because Trifacta uses a rule-based process, users can execute the same recipe on future datasets without having to redo the process, which adds a great deal of repeatability. This is a huge advantage over manual processes. To normalize our product size, we have to first extract the unit of measurement from the original product size column. I'm choosing the extract suggestion to create a new column with these values. We're also going to want to change the data type of this new unit of measurement column. Trifacta allows you to enter custom data types beyond the standard options available. So in this case, we've added units of measurement as a data type. When we select this as our data type, you'll notice that we now have some mismatched values here in red. If we dig into the column details, we will see that ounce is invalid, so we'll need to fix that. We've created a reference table called unit measure lookup, which we can use to replace invalid text with the valid abbreviations. We will perform a lookup to validate these values. So I'll click on lookup, select unit measure lookup, select the correct column, and I'll drop the initial column because it's no longer useful. And once we do that, you can see that all of our values are now valid. Now, we want to standardize the volume units by converting them all into ounces. So let's select milliliter. To do this, we're going to create another rule. So we'll choose set and we want to modify it. We choose the column product size 1, and we want to multiply those values in product size 1 by our conversion factor. Lastly, we want this applied to all rows containing milliliters. Trifacta guides the users through the transformation process. Each parameter of the function is explained, and immediate feedback is provided to validate that the correct rule has been applied. This is a great way to accelerate adoption and to start doing advanced transformations that were previously impossible without support from IT and data engineers. Lastly, we want to change our unit column so that it's all in ounces. So we'll again choose set and modify it, and instead of null, we want to set these values as ounces. We need to continue the cleansing and standardization of Acme attributes so that we can combine it with our own internal data. The item ID has to be extracted and restructured to reflect our own naming convention. If we brush over the retailer and item ID, you'll see that there are a few rows with an asterisk instead of an underscore. So we'll have to brush over those too. And we'll select Trifacta's suggestion to extract these values. Now if we drill into the column details, you can see that Trifacta has recognized a pattern. Some rows, the item ID has 20 digits, and in others there's only 19. Some rows have a different retailer name, which might suggest a merger, and others have even fewer digits. Let's select the 20-digit item ID and go back to our grid. You'll notice that this misses many of the rows. So let's modify this extract digit 20 function to include all digits. And I can do this by replacing the 20 with a plus sign. Now that we've extracted the item ID number, I can go up here and rename this column to item ID. And I'm also going to drop this other column because we no longer need it. One last thing, we know that Acme likes to add 4 digits to the end of their item ID. So we're going to just brush over those last 4 digits and choose the replace suggestion and add that to our recipe. This will allow these item ID numbers to match up with our own internal data. There's still a little bit of work left to do with the Acme data file to format, clean, and standardize it. But let's focus on the Globex data file that has a different set of issues. We just cleaned up the entire Acme dataset in a matter of minutes. The data that we had acquired had all types of issues, like missing and incorrect values, unstandardized units, and nested item IDs. And we fixed these data quality issues with ease. These problems would be nearly impossible to accurately identify and fix using manual processes. We can access other datasets in the same flow by clicking up here and selecting the Globex dataset. The Globex data seems to be better standardized. However, it comes with a particular formatting that provides the forecast quantity on a weekly basis. We need to unpivot these columns and turn them into rows so that it can be combined with our open orders table. To do this, we'll start typing pivot into Builder. And you'll see that we have the option of pivot and unpivot. Because we want to transform columns into rows, we'll select unpivot. And from here, we're going to select the first column that we would like to unpivot. We'll then add a tilde to specify a range, and after that we'll enter the last column that we want unpivoted. You can see in the transformation preview that the dates are now all in one column, and their corresponding order amount is in another column. Next, we'll need to convert the key column into a valid date. If we brush over the date, we'll select Replace to get rid of that, as it's not important to the column. Next, we're going to drag over the underscore. And this time, we're going to modify replace, and instead of replacing the underscore with blank text, we'll choose to replace it with a backslash. You'll see that after doing that, the key column now has the date data type. Really quickly, I'm just going to rename this key column to date forecast. Let's now assume that both the Acme and Globex datasets are clean and have a similar structure. We can now append the two of them together so that we have one single master forecast file. We'll open our fully cleaned Acme forecast dataset, and in order to append the Globex file to this Acme dataset, we'll start typing union into Builder. In case you're not familiar, a union is just a way to append the rows of one dataset to another based on matching columns, so we're going to select that. We'll add the dataset Globex forecast clean. You can see that we now have 7 matching columns between the two datasets. You can see here that unit of measure has no match column from the Globex file, but we happen to know that our volume column is a match, so we'll select the plus sign and add in the volume column. We'll go ahead and add that to our recipe, and Trifacta has now appended the two files together. Just as a quick check, we'll convert the vendor ID column to a string. And you can see that we do in fact have both the Acme and Globex vendor ID numbers. In that short exercise, we were able to solve a very complex problem of unpivoting data and appending it to create a single cohesive file that we can now reconcile with the open orders. If some of the original values were missing, not standardized, or not corrected for the forecast, that would cause a serious problem, endangering millions of dollars and cause a breach in the customer trust and overall business relationship. Now that we have appended our two retailer forecasts together, we want to join that master forecast to our MyCorp open orders. This will allow us to identify the forecasted items that have not yet been ordered. We'll type join into Builder to start the join transformation. We want to join this master forecast with our MyCorp open orders, so we're going to select that dataset. If we go to the join keys, we can see that Trifacta was able to predict the column key to join on, which in this case is the item ID. If we wanted to edit the join keys or add additional join keys, Trifacta gives us the ability to do that as well. We can select all the columns that we want to be displayed in our resulting dataset. So I'll click on All, and then click on the item ID from the forecasted dataset to remove that duplicate. We want to modify the join condition to be a left outer join. What this means is that in the resulting dataset, we want all the forecast rows, even if there's no corresponding order in the open order transaction dataset. This will highlight the missing orders so that we can contact the retailer to ask him to place the order accordingly. You can see that we now have a black portion in the item ID data quality bar. This is signifying that there are in fact missing orders. Now that we have joined both the forecast and the orders, we can explicitly mark the rows for which the order is missing. We'll click on the missing values in the data quality bar for the materials column. We're going to modify this set suggestion. We want to display in the rows with missing values, missing order for the forecast. To then highlight these missing values, I'm going to change this column to a numbered data type. And this will now show the missing orders as mismatched values. We just solved a major potential business issue through wrangling data. This is the value that Trifacta provides to thousands of users on a daily basis, and why we have such strong adoption, because we enable Excel or SQL users to manage very complex data manipulation very easily, and in a way that's actually pretty fun. In addition to capturing data issues that translate into critical business issues, Trifacta is also used to augment the data with various measurement metrics. One such metric the MyCorp team uses is forecast accuracy. Here we will calculate the order fulfillment to give you an idea of how we can proceed. In order to calculate the accuracy metric, we need to divide the sum of the forecasted quantity by the sum of the ordered quantity. This will give us the percentage of forecasted orders that were actually ordered. To do so, we first need to calculate the sum of the forecasted quantity for each item ID and the sum of the ordered quantity for each item ID. This might seem a bit complex, but it's super easy to achieve in Trifacta. To do so, we first want to create the sum of the forecasted quantity for each item ID. We want to create a new column with this value. So we'll select the item ID column and then select the quantity forecast column. We'll then choose the derive transformation. And if I click modify, you can see that Trifacta is summing the quantity forecast and grouping that by each item ID, which is exactly what we want. So we'll add that to our recipe. We'll quickly do the same thing with the order quantity column, so that we'll also get the sum of the order quantities. Now, we can calculate the fulfillment metric by deriving the following formula. We'll choose derive, and for value, we want sum of quantity ordered divided by sum of quantity forecasted. And there we go. Now we have our order fulfillment metric. Last thing we can do is run the job and publish our results. I'll go up here and select Run Job and quickly show you the publishing options that we support. You can output your results to a CSV file, or a Tableau TDE if you want to import it directly into Tableau. You could also publish your results to your Amazon Redshift data warehouse. As you've seen in this demo, Trifacta guided us through interactive exploration by predicting helpful transformations and giving immediate visual feedback each step of the way. From there, we were able to do more advanced transformations using Builder to guide us through each new step. We were then able to combine the two disparate forecasts into one master forecast that we then used to compare to our own orders to see which orders were not fulfilled. This allows us to better meet our customers' needs and build stronger trust between us. Additionally, we now have a repeatable script that we can apply to future orders, saving us time and hassle. All thanks to the incredible power of Trifacta.